In 2011, NASA's Messenger probe first entered Mercury's orbit and took some mind-blowing photos. On a planet that's so hot that lead melts, Messenger found deposits of billions of tons of ice. How is that even possible? Interestingly, despite Mercury often being closer to Earth than Mars, it's been explored the least among our neighboring planets. What else does this mysterious world hide from us? In this video, you'll discover where life could be hiding on Mercury, how it threatens all life on Earth, how this planet can provide future humanity with endless energy, and, in general, what secrets about Mercury will turn everything we know about it upside down. In reality, Mercury is perhaps the trickiest planet to investigate. This is despite the Babylonians observing Mercury 2,000 years before our era and including it in their star catalogue. They were extremely surprised that Mercury occasionally seemed to move backward across the sky. The Babylonians couldn't explain this weird phenomenon. Later, ancient Greeks noticed that Mercury moved faster than other planets, so they named it after the swift-footed messenger god Hermes. His counterpart among the ancient Romans was Mercury, in whose honor we still call the planet. Only in the 16th century did Galileo Galilei finally explain Mercury's peculiar motion. It revolves around the Sun much faster than the Earth, causing it to pass us several times a year. This creates the optical illusion that Mercury is moving backward. This is the same retrograde Mercury that astrologers baselessly blame for all the troubles in your life. Galileo cracked this mystery thanks to a groundbreaking invention, the telescope. But due to the planet's proximity to the Sun, studying Mercury through magnifying lenses was incredibly tough and even risky for the eyes. Even the mighty Hubble and James Webb telescopes today hesitate to point their gaze at the planet closest to the Sun because their equipment might not be able to handle its flares. So should we just launch a spacecraft to Mercury? Actually, it's not that simple. To get closer to the Sun, any probe needs to significantly slow down. For the Mariner 10 probe in 1973, they devised a complex orbital route to break around Venus. The craft only reached Mercury's orbit the following year and orbited the planet 3 times. It captured the first photo of Mercury's surface, which, with its craters, strongly resembled the Moon. To scientists, this gave rise to the theory that they shared a cosmic ancestor. But a chemical analysis of their surfaces showed that Mercury and the Moon are entirely different. The real surprise for scientists was that Mercury spins around the Sun entirely differently than the Moon around Earth. Typically, a smaller celestial body at a short distance from a larger one always turns one side towards it. But Mercury does rotate on its axis, just incredibly slowly. So slowly that a day on Mercury lasts a whopping 176 Earth days, twice as long as a Mercury year, which is 88 Earth days. That is, one day on Mercury lasts 2 years. Wrap your head around that. And Mercury has more surprises up its sleeve for scientists. See these tails glowing from Mercury like someone signaling us with cosmic spotlights. They've been a long-standing mystery. Could Mercury really be a giant comet? That'd be absurd. Before the Mariner 10 mission, scientists thought a planet a third the size of Earth simply couldn't have a magnetic field. Observations from Earth telescopes back that up. But the spacecraft indeed detected a faint magnetic field capable of causing magnetic storms, yet weaker than expected. It's precisely these storms that attract hot solar wind plasma to the planet's surface. Hitting Mercury's surface, it pushes neutral-charged atoms upwards. It's like water splashes during a jump into a pool. That's how those quirky comet-like tails are formed. But where did a magnetic field come from on tiny little Mercury? It can only exist due to circulation in the molten metallic core. But how did such a small planet keep it when even a planet twice as large as Mars is almost entirely cooled from the inside? During the latest Messenger probe mission, scientists found out that Mercury's core is abnormally huge, occupying 70% of its mass. Earth's core, in contrast, is responsible for only a third of Earth's mass. This explains why Mercury hasn't cooled from the inside yet but creates a new puzzle. How did it get such a colossal core? According to one theory, billions of years ago, a massive celestial body collided with Mercury, causing it to lose a substantial portion of its outer rocky layers. But recent studies suggest that the responsibility for Mercury's large core lies with the Sun. Back when our young star was surrounded by gas and dust clouds instead of planets, its magnetic field was pulling in iron particles. So the closer the planets formed to the Sun, the more iron they had in their mix. That's how Mercury managed to grow such a disproportionately large core. But this planet's play with our expectations was just beginning. Mercury has things it shouldn't have. Studying images of its surface, scientists saw that it's entirely covered with large rocky formations resembling steps in a landscape. They stretch for hundreds of kilometers. The longest of these rocks reaches 1,000 kilometers. According to the leading theory, this is a result of the gradual cooling of the planet's core. It shrinks and wrinkles, similar to how grapes turn into raisins when drying. However, scientists believe that if these rocks appeared only due to the core's reduction, they would be evenly distributed across Mercury's surface. Instead, it turns out that most of the rocks are concentrated in two bands on opposite sides of the planet. Some scientists speculate that this relief is due to the expansion and compression of the mantle layer, while others believe it's too thin for this. What stumps scientists even more is that there are twice as many rocks in the southern hemisphere than in the northern. Explaining this anomaly is currently mission impossible. To shed light on this mystery, the BepiColombo probe was launched towards Mercury, set to approach the planet in 2024. The first distant photo taken by the probe only added more intrigue as it clearly showed new Mercury wrinkles. So check this out, the smallest planet in our solar system keeps on shrinking. And it seems like it's not just about the core cooling and squeezing. Chemical studies showed that Mercury is loaded with volatile substances like water, sodium, carbon dioxide, and mercury. Over time, these compounds vaporize through the surface and theoretically could be creating these new young rocky formations. But the high concentration of light materials on Mercury is a real head-scratcher. I mean, the Sun should have evaporated them ages ago. So how did Mercury manage to hold onto its volatile riches for over 4.5 billion years? One explanation suggests that this planet actually formed much farther from the Sun, but eventually hitched a ride closer due to some gravitational pull. According to one hypothesis, Saturn's gravitational influence caused Mercury's migration. Hold up, didn't Mercury need to form close to the Sun to have that big metal core? Something's not adding up. And add to that an abnormally large amount of water ice. Even though temperatures on Mercury can soar above 400 degrees Celsius, it's not that surprising that remnants of ice can linger deep in crater shadows and at the planet's poles. But get this, scientists found there's more water on Mercury. Where does all this water come from on one of the hottest planets? Paradoxically, water on Mercury might appear thanks to the Sun's activity. The planet's surface contains linked oxygen and hydrogen atoms known as hydroxy. On their own, they can't form water. But protons from the solar wind can penetrate Mercury's surface, where hydroxyl hides. This activates linked oxygen and hydrogen atoms, making them slam into each other, forming water molecules in the process. Some of these molecules evaporate through the atmosphere into space, but the rest manage to land on shaded poles and settle as icy formations. Even though this process is pretty slow, scientists estimate that in 3 million years, Mercury can accumulate nearly 10 trillion tons of new ice. That's like 46 Columbia Glacier in Alaska. So, does this mean colonizing Mercury will be easier than Mars? Especially since Mercury gets 6 times more sunlight than Earth and could easily power a colony for centuries ahead, and not just one. So, why aren't we there yet? In fact, settling on Mercury is not the best idea. Though scientists are eyeing Mercury as a cosmic solar power station for humanity's future needs, the road to that is far from smooth. The Messenger probe took 7 years to enter Mercury's orbit. It orbited Earth, Venus, and Mercury several times to slow down enough. Would you sign up for spending that much time on a colonization ship? Landing on Mercury won't be easier than getting there because it has almost no atmosphere to help slow down a spaceship. It could be the trickiest parking job in the world. The extreme temperature swings from -180 degrees Celsius at night to 400 degrees Celsius during the day will either fry or freeze you. Here, the colonist will find solace in the duration of Mercury's day, which is 176 Earth days. This will help determine the time and place for landing at a relatively safe temperature. But still, Mercury can throw you a curveball because, due to its unique orbit, the Sun can rise twice in a row. So, even if you land during a warm sunrise, you should still be ready for chilly dusk. If your spacesuit shorts out from the temperature swings, you're in for a rough ride. Mercury's low gravity creates almost a vacuum. This will literally tear your lungs apart, and your blood will start to boil. In 15 seconds, you'll lose consciousness due to lack of oxygen, and your fellow colonists will have about a minute to save you. Spacesuits should be well adapted for the harsh Mercurian conditions, and it'd be great if they're suitable for mining, as you'll have to do a lot of digging to survive. During the Messenger mission on Mercury, they found lava tubes, remnants of past geological changes. Some are deep enough to build an entire city inside. Inside the tubes, you can maintain an optimal temperature around 21 degrees Celsius. Thanks to the airtight conditions, it's entirely possible to artificially recreate the Earth atmosphere and feel comfortable without a space suit. Also, beneath Mercury's surface, you'll be shielded from intense radiation. Another way to survive on Mercury is not to stay in one place. For this, you need to construct a mobile settlement that keeps moving west, riding the edge between scorching day and icy night. Since the sun rises incredibly slowly on Mercury, the speed of your home could be quite moderate. Still, the best option for now is building cities in craters at the planet's poles. Some of them are up to 100 kilometers in diameter, and they could easily fit megacities like Beijing or Tokyo. So, building a full-fledged city in a crater is entirely realistic. Its walls will provide excellent protection from the sun, and on its upper edges, you can install solar panels to extract energy. With this setup, there won't be any issues on Mercury for sure. The most significant advantage is a constant water supply. Thanks to a special system of mirrors, you could even create conditions for growing plants. It's better to cover the entire crater with a massive dome to maintain a comfortable microclimate inside. But even when you manage to escape the biggest threat, the sun, Mercury's gravity will still mess with your body. It's 3 times weaker than Earth's. On one side, it might be fun because you can leap over vast distances and easily lift much heavier objects. However, recent studies show that weak gravity can lead to muscle and bone atrophy, and even vision and cardiovascular problems. So, the new generation of Mercurian colonists will be significantly leaner than us, with weaker muscles and thinner bones. Their bodies will stretch, and their eyes will darken due to the bright sun. These would be real aliens. But what if they aren't the first living beings on Mercury? Deadly Mercury might be hiding life from us right now. Technically, Mercury has an atmosphere, but it's so thin that scientists use the term exosphere for it. That's when the density of molecules is so low that they don't even collide. But even in it, they find molecules that could indicate life. Oxygen and water vapor are signs of breathing, and methane is a sign of life waste. No known organism could have survived in the infernal temperatures of Mercury, and no liquid water that could foster life has been found on Mercury's surface. But what about those underground caves? We figured out that not all the volatile compounds, including water, have evaporated from Mercury yet. According to research from Alexis Rodriguez at the Institute for Planetary Sciences in Arizona, if water compounds still hang out in Mercury's exosphere, it's quite probable that deep within the planet's lava tubes lies a stash of not frozen, but liquid water. If that's the case, there might be entire reservoirs hidden at great depths in those lava tubes. Considering the biosignatures found in Mercury's exosphere, what if a whole Mercurian ecosystem lurks in those deep, water-filled lava tunnels? But what if life on Mercury is more advanced? Recently, the BepiColombo probe discovered something odd around the planet, an abnormal surge of electrons triggered by X-ray radiation. Essentially, it's an invisible radioactive aurora. Previously, this sort of thing was observed only on planets with thick atmospheres, where charged solar particles could interact with atmospheric gases. With Mercury's thin exosphere, this should be downright impossible. But what if those are traces of an underground Mercurian civilization using solar flares to recharge their generators? While we're getting worked up about life on Mercury, it could well be plotting the end of life on Earth. Mercury's orbit is quite stretched. At different points, it swings within 47 million kilometers of the Sun and drifts away to 70 million kilometers. Astronomer Jacques Lascar from the Paris Observatory, thanks to his computer simulation research, found out that over time, Mercury's orbit under Jupiter's gravitational influence will stretch so much that it'll cross Venus's orbit. This will eventually lead to an inevitable collision between the two planets. As a result, Mercury will start chaotically cruising through the solar system. The safest bet for us would be if the planet crashes into the Sun. But according to Lascar's study, there's a chance Mercury might slam into Earth. Due to Jupiter's predominant influence, that could be the grandest catastrophe in our planet's history. Just for comparison, the asteroid that wiped out the dinosaurs was just 10 kilometers across. Meanwhile, Mercury's diameter is almost 5,000 kilometers. So, if they collide, there won't be anyone left alive. Even colonizing Mars might not save us because a knocked-off Mercury could make its way there too. Though Mercury's movement might cause us a heap of trouble in the future, luckily, there's only a 1% chance it'll hit the Earth. So, with 99% certainty, Mercury won't pose a threat to us for the next few billion years. Unless Papi Colombo discovers unknown factors that not only flip our understanding of Mercury but also present a new threat. For now, we're more dangerous to Mercury than it is to us. According to the theory of Soviet astrophysicist Nikolai Kardashev, for humanity to advance to a Type II civilization, we'll need to harness the Sun, utilizing all of its energy. This will require building a stellar generator, a Dyson sphere. It's a colossal engineering project, and Mercury is poised to help make it happen. It's not just about deploying construction on it. Canadian futurist George Dvorsky suggested completely dismantling Mercury to extract resources for the Dyson sphere. The large iron core would come in very handy here. But is it really worth it? Or is it better to just fly tourists to Mercury to witness a double sunrise?